Good afternoon, students. In last class, we have discussed about calculation of sag, that is supports at equal level and unequal level, and also we have solved problems on that. And today we shall discuss about the vibration of conductors and damper. What do you mean by vibration of a conductor? These when like a strong wind. The conductors are supported on the string insulators at each level under widely varying atmospheric conditions like strong wind. For example, any summer season or wind season for some days or for some months or for some weeks. Okay, wind season will be there will be lot of strong wind, so vibration in the conductors, it may be like this. Okay, it will be swinging. Okay, it is a oscillation, it will be. So that is what vibration, that will be constant. Okay, the vibration of conductors, how to hold that. uh, Vibration of conductors, the conductors are supported on the string insulator. Okay, you'll read in detail about insulators in this module only. Okay, at that situation I'll say about where the conductor is connected, you will come to know. Okay, here during atmospheric conditions like strong wind velocities, the conductor can start vibrating mechanically in the vertical plane. Okay, it may be vibrating in the vertical plane or horizontal plane. Such vibrations have different frequencies, amplitudes and modes. There are two types of vibrations in the vertical plane. They are saying that one is Yolin vibrations, and second one is galloping or dancing of conductors. First one is that is that vibrations have the frequency range 8 to 40 hertz with the amplitudes varying between the 2 to 5 centimeter. It have a frequency range is 8 to 40 hertz and the amplitude is between 2 to 5 centimeter. Next, vibrations have high frequency, low amplitude vibrations. These are the vibrations, high frequency. It has high frequency and low amplitude. The wind velocities of about 2 to 40 kilometer per hour can generate such type of vibrations. Okay, this wind velocity of about 2 to 40 kilometer per hour can generate such type of vibrations. And next, the frequency of Earlin vibrations. Earlin vibrations is given by, that is F suffix A is equal to 2 into Vp divided by D into 10 to the power of 3. That is, Vp is nothing but wind velocity in kilometer per hour perpendicular to conductor, and D is the diameter of conductor in meter. These vibrations are not much harmful, but if the frequency of vibrations coincide with the natural frequency, they have given that frequency is for 8 to 40 hertz. Okay, if the frequency of vibrations it is coincide with the natural frequency of the conductors, then resonant condition can be achieved. This will result to breaking of strands and mechanical failure of the conductor. Okay, what it will happen means, if the natural frequency and the vibration frequency, if it is coincide, then the resulting is resonant condition that will lead to breaking of strands. Breaking of strands means conductor. Okay, the conductor, mechanical failure of the conductor. Okay, bundled conductors and proper design and locations of spaces and clamps and use of dampers can minimize the effects of yearly vibrations. But how it can be minimized means, this effect use of bundled conductors also you will read in this module only. Use of bundled conductors and proper design and location of spaces. Clamps is nothing but holding a conductor like this. Okay, for example, this is a conductor like this. Okay, like this. Then clampus is holding a conductor, and use of dampers, it can minimize the effects of Yolin vibrations. Next, galloping of conductors. Galloping of conductors, they high frequency, low amplitude. Here, low frequency, high amplitude. It causes the longitudinal movement. It causes the longitudinal, like this. Okay, longitudinal movement of conductors through the conductor clamps. Through the conductor clamps, the frequency of galloping are about, here frequency is 0.25 to 1.5 hertz with the amplitude of about here 6 meter. Okay, one loop, two loop, three loop. The conductors will be like this. Okay, galloping, dancing. Galloping is wave but possible mainly in rainy or snowfall conditions. Okay, it is wave, but in rainy and snowfall conditions, sometimes it happens. Okay, there no methods by which galloping can be restricted. Yeah, but in icing conditions, height of the icing conductors can be designed properly considering the amplitude of possible galloping. Vibrations are longitudinal, horizontal configuration of conductors can avoid clashing of conductors during galloping. Next to stopwatch type vibration dampers. What does it do? A damper used to restrict Aeolian vibrations is called stopwatch type damper. You can observe, this is the figure how the conductor is holding. Okay, how you can observe. Okay, this is a clap. This is nothing but it looks like a ant. Okay, this is a clamp, this is clamp, this is conductor. Okay, downside bridge. Okay, this is a stock bridge. Here bolt is connected, bolt is there, and this is a galvanized iron weight. Okay, a damper used to restrict Aeolian vibrations is called stock bridge type damper. It consists of a steel cable. At the two ends of the cable, two hollow shaped weights are fixed. The main feature of the damper is the grip of the damper with the conductors uses only one bolt here. Here they use a 1 volt. Another feature is that dampers can be fastened to the conductors even though the line is alive using a special long handling tools. And next, special shaped weight actually acts as a dampers. The damper acts concentrated mass at single point on the conductor. The vibration energy due to hysteresis and inner strand friction get absorbed by the damper. Next, depending upon the span and size of the conductors, the number of dampers and their locations are selected. Depending upon the span, distance between the two towers, depending upon the span and depending upon the conductor size. Okay, conductor size, that is the number of dampers where it should be located, they will decide. Okay, and here the damper acts as a concentrated mass at single point on the conductor. You can observe here. Okay, this is a damper set. Damper. Next, factors affecting conductor vibrations. What are the factors affecting here? Atmospheric conditions like icing, rain, and high wind velocity. And next is a span of conductors and tension in conductor configuration, type of clamps used, height of the towers. These are the factors that will affect the conductor vibrations. First is we shall know about the arcing horns. What is arcing horns? The main cause of an insulator failure is flashover, which creates an arc through an A surrounding the insulator. You can observe here, this is a insulator. You'll read in depth about in next classes. Types of insulators are there. Okay, this is a insulator string. This is a insulator string, or this is a insulator string, and this is a line side, and this is a tower side. Okay, this is a flash, bypass, and arcing ons. These are the arcing ons. What does it do? Okay, the lighting strikes, switching surges, and electrical faults are responsible for flashover. Okay, these are the responsible for flashover. And what does used to this arrangement is used to protect the insulation or insulator from arcing conditions due to flashover. Okay, this will prevent the insulator. Arcing ons will prevent the insulators from arcing conditions due to flashover. Okay, this is the main arcing ons. Okay, the arcing ons have the metal rods. You can observe these are two are the metal rods, this one and this one. These two are the metal rods constructed in the form of projections on both sides of an insulator. On both sides it is, for example, this is a insulator, means for both sides it is available. Okay, two sides it is connected. The arcing ons have a large spread on both sides, transmission tower side and conducting line side of an insulator. When there is a lighting surge, then arcing ons prevent the arc formation. Okay, if for example any lightning, rain is coming, lightning will occur. If any lightning surge, then that should not affect to the insulator, and that should not lead to the conductor failure or whole system failure. So to prevent that, when there is a lightning surge, the arcing ons prevent the arc formation across the insulator by conducting the arc across them only. For this to happen, the gap between the horns must be much less than the length of the insulator. That is, for example, like this it will be. Okay, the gap between these two fingers, the nothing but these are arcing ons. Between these two, that is between that arcing distance ons. For this to happen, the gap between the horns must be much less than the length of the insulator. It should not, the gap between the horns should not be equal to the insulator length. It should be less than the insulator length. Okay, if we take this as an insulator, then the between arcing ons it should be less than this. Okay, less than the insulator. That is what arcing ons. This is a effect of atmospheric conditions on transmission line. This we shall discuss in next class.